Okay, I hope I did not talk to nobody for the last 15 minutes. I just got the message that the broadcast started.
I didn't click the right button, but now it is fixed.
So should I start over or?
Yeah, if you or just go quickly. You're only 2 slides in.
Yeah, but nobody could hear me the last 10 minutes.
Yeah, so just
Okay,
sorry.
welcome again. Okay, we will go 11 minutes over at least. So welcome to presentation SLA first, solution later. This talk is about how to establish a service level agreement and from that derive an HADR operational solution for SQL Server. So why I think I'm qualified to talk about this, I'm old. I worked with SQL Server for 25 years. I've worked since 1994. And I've run systems in every size and company size you can imagine. I work a lot with Microsoft to improve the product, give them feedback, work through cases with them, show them showcases from the real world, and explain to the engineers what's going on. And I'm running through this fast, so we keep up the time. Agenda. So we're going to talk why we need an SLA and when to establish it. We're going to discuss what's in it and how to get to a successful SLA and how to build an infrastructure out of it, and then open up the floor for questions and answers. So why do we need SLAs? SLA is a very simple thing. It ensures that management and the people around you in a company, and it doesn't matter which size the company has. It can work for a very small company, it can be for a very, very large company. It's all the same thing. Everybody has to agree to the same reality. If someone dreams that the machines will always running and the other person knows for a fact that that's not the case and they don't talk to each other and then they'll come to an agreement what is the reality in the company, everybody will be unhappy over time because the expectations of people are not met. And the service level agreement is a very simple way of getting everybody on the same page and having everybody understand in writing what to expect and how much it's going to cost to get there. Yeah. It also helps you argue why you need an additional server in a second data center to provide the availability for the database and so on. And we'll get to the details. And the third reason is to avoid lawsuits. If it's written down, this is how it works. And as long as it works as it's written down, there's no need for a lawsuit. If it's not written down, someone might think, hey, I expected it to be up and running all the time. The person who operates it says, I knew it's not going to run all the time. I know it's going to be off half the time. So it helps avoiding lawsuits. And by the way, this was the original title of the presentation when I gave it the first time a couple of years ago. Rule number 1. SLA has to come first. You have to write down the expectations, what people want, what is needed, what's actually the reality of what we need. And especially if the company gets bigger, it's really funny. I work in a company with about 800 people right now. And if I ask 3 different teams about their needs and what's important, I get 5 different answers. And part of establishing the SLA is to find the people that can actually make a judgment. And it's clear, in a large corporation, one way of keeping people happy and working there is making them feel they work on the most important stuff. So if you ask everybody what's the most important thing, they will tell you whatever they work on. So you have to go really high in a company to find a person that actually knows which parts are important and which not. A good example from the past is I worked with a pharmaceutical company, and it turned out if their complete IT is down for a day or 2, they didn't care because their production systems were not tied to IT. They were all independent, and everything that was triggered by IT, like the part I was involved, printing labels for medicine, they printed them a week in advance. So if the system was not running, they could just do it tomorrow or in the afternoon instead of the morning. So they were not dependent, the production was not dependent on it. Given this was 10 years ago, so it might have changed by today, but it shows it. Or another example is I worked for a hedge fund, and their trading guy says The only time every day we need the systems to be running is from 4:50 till 5 p.m. Rest of the day, if they're running, it's great. It makes our job easier. The only time we need them actually running, 4:50 to 5. If they have a problem at that time, it can cost the company a lot of money. And we arranged our systems to meet that. Yes. Second thing, after you have an SLA, it's much easier to build a solution. You have written down exactly what's needed. You can use the SLA to argue all the resources. And you basically have a blueprint and an answering document that gives you an answer to every question you have. If you have a solid SLA, how to make a decision for the solution and what to pick. Yeah. And I know that's great and sounds awesome in theory, but in practice, you will have cases where you don't have, you already get thrown into an existing environment, but you should never agree to a service level agreement that you know that the current solution that's already in place cannot support. I see so many times when other people I meet at the past summit or SQL Saturdays and we talk and they're like, yeah, my company wants me to support 99.9% uptime. And yeah, I don't know what should I do? It's like, do not agree to it unless you are sure you can do that, because there's a big chance that you will not be able to actually do that. Yeah? And this can into trouble, especially if parts of your bonus or something are tied to actually managing that SLA. Because one part of the talk is going to be explaining how hard it's actually to guarantee an SLA versus just randomly making the numbers. So what should be in an SLA? And it's a very simple answer, everything. But we all know that's a dream. But what should be in it? Operational requirements. What is actually required from that system to do? Yeah, write it down. It's very different to build a database solution that writes down the instant messaging of a social media platform versus a database platform that handles billions of dollars of financial transactions. And it's probably very, very different of some survey system that asks people questions on the internet, or very different from a gaming platform where people spend money to play multi-user games. Right. The next one is more super important, maintenance windows. When can the operational stuff take the systems down? When can they turn it off to do some maintenance? When can they run backups, kind of run DBC check DBs, run index rebuilds? Because this needs to be noticed. My current company, every Friday, 11:30 p.m. till Sunday, 11 a.m., we can do whatever we want to the systems because there's no trading in the financial industry on the weekend. Previous company, the online gambling company, we could do maintenance Easter Monday every year for 2 hours. Very different SLA, very different mode of operating. The thing is, if you only have 2 hours a year to rebuild your indexes, you plan very carefully which ones you can do. If you basically have a day and a half every weekend, you do them all and don't have to worry about it. So slight difference in the SLA, very big difference in how to operate it. The next point is responsibilities. What is that system and the people that operate it actually responsible for? I've worked in companies where the DBA team was responsible for storage, network, the servers, SQL Server, and the content of the database. I've worked for companies where the DBA team was only responsible for maintaining SQL Server instance. They were not responsible for what's inside the databases. They were not responsible what's on the hardware. They were just responsible for the little piece of SQL Server.exe and that this was running smoothly. Yeah? So every company is different. Again, it needs to be written down. Hey, this is an OS problem. It's great. We can help you debug it, but the team that has to fix it is actually this one and not us. Next one, dependencies. It's very rare, especially in a larger company, that you don't have dependencies on other systems. Yeah? If you run SQL Server in any form of cluster configuration, be it failover clustering or um, always on, you'll have most likely a dependency on Active Directory. The moment Active Directory is gone, your clusters will not behave the way they are. I know there's new features in the latest versions that you can go without AD, but I've rarely seen them be used. Yeah. And then what happens if the SLA is not met? What happens? Yeah. I like this when I read the SLA from the cloud operators, because they always want us to come to the cloud, and we're like, yeah, we're trading $1 trillion a month on this platform. So what's the SLA? Yeah, what happens if it doesn't work? And then they tell us, yeah, we give you 1 month credit. I'm like, yeah, that's great, but that doesn't help us if your databases don't work, and then you give us like $100 credit, and we just lost $10 billion because we couldn't trade for 3 hours. Yeah? So again, people have a different. What does it mean if an SLA is not met? Yeah? Will it have an impact on the bonus structure? Will there be committees that look at what went wrong, like a post-mortem that figures out what's wrong? Will there be changes after it? Is it just ignored? So very different what happens if the SLA is not actually done. So coming to more details, what should be in an SLA, especially looking at databases. SLAs for web servers also look slightly different because databases have this duality. A database server is both code and data, while most application servers are just code. So it's easier to recover them, because on SQL Server, if it's just about the configuration and the installation of the software, that can usually be fixed in a very reasonable short time frame. But when it comes to also recovering the data, depending on the size, this could be a very lengthy process. So the first thing when it comes to data and specifying an SLA is the recovery point objective, RPO. Or in plain English, how much data can we lose? And this is one of the toughest questions to ask management. Because, I mean, what are the answers you're going to expect? Yeah? Nothing, none, I don't know, and anything else. Yeah? But in reality, this is a very tough thing, because, I mean, I've never seen a DBA that went to work in the morning and says, today I'm planning on losing 11 minutes of data. That never happens. Every DBA will always try to lose no data, yeah? Because that's his reputation, that's his pride, and to be honest, it's his job. But Murphy and many other IT obstacles are in the way of succeeding in that endeavor of creating zero data loss. So the reality defines how much is it. Yeah. So if I have a log backup that's 12 minutes old and all my systems are down, and I can't revive them, I'm probably going to lose 12 minutes of data. Yeah. If my last full backup is from a week ago, there's a chance I will lose a whole week of data. Yeah. You do not have a backup, there's a good chance all your data might go away. And unfortunately, there's a bunch of cases on the internet, even after doing this for like 50 years. So relational databases are on the world, in the greater public, for 50 years. There's still people out there that run them without a single backup ever. Yeah? So this can be hard. Yeah? And I worked for companies that had a zero data loss policy. We have to do anything humanly possible to not lose data. And I worked for companies where it was like, yeah, it would be tough if we lose a whole week, but since we print a copy of every invoice, we sort of could regenerate it from paper. And that's, again, how much money do we want to spend on high availability and data protection? What are the chances that you actually lose all your data for a whole week? Very different, and might make sense to not spend too much money. Other places might be very different. Yeah? Just imagine the two main cases I come to. You have a fully online shop. That's the only place you sell stuff. Yeah? If people enter it on your website, that's the only place that ever sees the order. If you lose that data, there's a very high chance that person will never order again, and that order is going to be lost. If you work for still a mail order processing company that sends out catalogs and then gets surface mail orders back, if you enter them and then after a full day you lose all the data, it's going to cost you paying everybody overtime to re-enter the data. But technically the data is not lost. So the question is it cheaper once every 2 or 3 years to pay 20 people overtime for a day? Or do you run multiple copies of your database in multiple data centers to fight that? Again, depends on every case. The important thing is you have to write it down. This is what we need, and this is this is our actual needs, and this is how you can lower the cost of the operations by figuring out what's actually needed. Because the first time you ask people, they always want it has to be running all the time, and we cannot lose any data. Next point, recovery time objective, RTO, or in plain English, how much time after a failure till we have to be up and running again? And again, that varies very much from company to company. Already give an example, my pharmaceutical company I worked for. Hey, something fails, you're up and running tomorrow again, everybody's happy, we have things to do for everybody. Let's be that our recovery time objective, it's 16 to 24 hours. I work for the gambling industry. It's like, hey, you can be down as much as you want. We're taking away $100,000 from your bonus. Every minute you're offline. And that was the bonus for the whole team. But trust me, an hour and everybody was weeping because that means no bonus that year. Thing is, examples. A restore takes 6 hours, so you're going to be offline for 6 or more hours. And this is something that the recovery time objective is often forgotten. Yeah? There's multiple ways of how recovery has to happen. The easy case is you have high availability, one server goes down, 2 or 3 minutes later, all the services are transferred to the backup system. You have availability groups, database mirroring, failover clustering. You basically have a couple of minutes outage, and then you run on the other side. That's the recovery time objective for high availability. But there's the other case when something severe happens and your data gets corrupted or accidentally deleted, then you have to go back to the last backup. And in most systems, backups don't restore very quickly, especially the ones that use very expensive tape solutions that do deduplication and save a lot of money in taking the backups. They have cases where it takes like a day to get the data back from the tape, because it's already magically deduped in some place where it takes forever to pull it out. So you have to specify, hey, if everything goes wrong, and this everything goes wrong, there's a very simple explanation. Part of the application rolled out and there was a delete statement, and someone forgot to attach the where clause to the delete statement. So instead of deleting one customer, the first time it was called, it deleted all customers. There's no HA or DR technology on the planet that can help you prevent that. Yeah? But you can still use backups to get to where you need to be and to recover from that point. Right? But that will take a lot of time. And yes. Imagine the last backup that just took you 6 hours to restore doesn't work because it's corrupt, because the error that made you restore was already in the system when you took the backup. Now you have to go back to tape or find the backup before that. That might take you more than a day when the first one took you 6 hours. Yeah? So this can quickly escalate. And again, if it's agreed that this can happen, it's fine. If it's in the SLA, this cannot happen. You have to, and this is what we're going to learn later on in the talk, have to build a solution that allows you to restore in less than 6 hours. And it could be as simple as much as you're spending 4 times as much on your hardware and everything runs twice as fast. 6 hours become 3 hours. Everybody's happy again. But then you have to take into account in 3 years from now, you're probably going to have twice as much data, and then you're back to the 6 hours. So another point in the SLA that needs to be in there is how to deal with data growth. Because today you can restore, when you create an empty database in the first 6 months of operation, you probably have a couple of gigabytes in it. Yeah? After 10 years hoarding the data from every transaction the company ever did, and suddenly you have a 20 terabyte database that takes almost a day to restore. Availability. This is something everybody wants defined in their SLA, and then you ask people, what does it mean? And the definition in English, sort of, is the time the database is available within a period of time divided by the length, the period of time. Great. So we're all very bad at math. So it's the time you're actually running versus the time that has passed. So if it's a year and you ran 360 days out of the year, and the other 4 days you were down, your availability is 360 divided by 364 or 65. The biggest problem I see when it comes to availability is that people confuse it with luck. Quick story, I work for online gambling industry, and every year we move to Microsoft and we give an awesome report about how many nines we achieved last year. And then one year I gave a report and says, this was the most horrible year ever. We didn't achieve a single 9 in our availability. Yeah? And if you don't know what I'm talking about, ability is measured in percent. So 99.99% is considered a very high availability. I said, Microsoft, there wasn't a single 9 in the whole availability. And everybody was shocked that the managers at Microsoft were panicking. What's going on with SQL Server? That's impossible. And he says, yeah, there's no 9 in 100. We were running every second of the year. We were not down a single second in the whole year. But I didn't want to take credit for that. I mean, I had no problem messing with Microsoft, but that wasn't because the database team did an awesome job. We just got super lucky that nothing happened in the whole year. Nobody tripped over a power cord. Nobody accidentally shut down the wrong machine. Nobody messed up a rollout. Yeah? This is just an insane pile of luck. Yeah? Because it's, yeah. How fast do you think you can fix data corruption or human error in your database? Yeah? This can take easily hours or days to figure out what's wrong. Yeah? While on the other hand, there's having 100% availability or 99.9% or something like this is super easy. It's not that hard, but guaranteeing it, yeah, is close to impossible. The moment you go to any availability where the time that you can be offline is measured in minutes, it's getting too impossible. Just imagine the failure happens in the middle of the night. It might take 3 or 4 phone calls to even wake someone up that can take a chance, and then they have to remote in or have to drive to the company. You're missing a spare part that has to be delivered. That's a lot of time that can pass. So yeah, the famous 9s. I've seen the most hilarious numbers: 99%, 99.7, 5 9s, 6 9s. There's a storage system that like puts on their website 7 or 8 9s. Overall availability of the whole planet. Yes, that's great. I still had with that storage system a 2-day outage. It's great that the average availability on the whole planet was 6 9s, which means like 10 milliseconds per day per year. I had a 24-hour outage. Technically for them, it wasn't an outage because the storage system was up and running and could deliver hours. I just couldn't add any more data to it because the storage system believed it was full, while it technically wasn't full. It was just still not done with deduplicating all the data that we threw at it. So that brings me, let's go to this slide very quickly. I just put that in for reference. Yeah? If you get 0% availability means you're the whole year off. and the year in technical terms is 365.25 days. This takes into account that every 4 years there's a leap year. That's how many hours. So when you look down at the 5 nines, which is the second line from the bottom, you see that you can be offline 5 minutes a year. 5 minutes a year is nothing. I've seen many companies where the monitoring system only checks the systems every 5 minutes. And it says, we have 99%, 99.99% availability. Like, I don't believe that. I can fail over a cluster and you won't even notice, because I just wait till the check comes in, then I fail over. So I have 4.5 minutes to fail over and get everything ready again. And then your monitoring system checks again. Technically, I was 4.5 minutes offline. You didn't notice because your monitoring is not checking for 5 minutes or more. And this is the most important thing on availability. What does available mean? And this is always ask the questions to people that start in a DBA. What do you mean with available? Is a database available when I see it's online in SQL Management Studio? It says online, must be working. Or is it online if I can actually log in and open the database? Or is it online if I can select data from the database? Or is it offline if I can do all the above and actually update data? Or is it actually called available when I can insert new data? Because I might have a full database with no extra space, but as long as I just update or select the data, nothing fails. Every time I try to insert the new row, it fails. So is the database available or not? Depends, point of view. If all you do in the database is read old data, it's fully available. If you try to store new data, you would consider it's not available. So what is the reality? What is the truth? Again, the SLA has to define under which circumstances, at which point in time, and every day, what available means. Can I change the schema? I've seen databases that had a corruption that was in the metadata. You could add trillions of new rows, wouldn't be a problem. You want to change a single table, it says this one can't work. So is the database available or not from an operational point of view? You get the idea. There is the definition what online means or not. Many years ago, there's a perfect demo from Kimberly Tripp where she shows one of the features, the partitioning features in SQL 2005, where she on stage literally yanks out a USB stick from her laptop and the database continues to run. And as long as nobody queried any data that was on that specific USB stick, there were no issues. The moment the access happened or someone was selecting data from that stick, it showed, hey, no, I don't have that data. So am I now offline or not? Again, a question that has no simple answer that's always true. It's the case and different for every company. And within a company, every system or even every database might have a different definition there. And I'm not saying go overboard. Just don't specify a super high SLA for a simple database that doesn't need it. And on the other hand, don't put a very low SLA on a database that actually needs it. Figure out how important it actually is, then deal accordingly. And don't even get me started on defining performance. I'm still trying to crack that in every case because that's a really thing. If a database is fully operational, but everything that's twice as long as normal, is it considered available or not? And honestly, I can't give you an answer. There's cases where it's very clear, no, that's not online because we need to process 300 orders and we can only do 150, so we're clearly not available. We are partially available in some form. But there might be other cases, yeah, instead of printing the labels 2 hours, it took us 3 hours. Is it inconvenient? Yeah, but is it the end of the world? No. So again, 2 cases, exact same scenario, machine takes longer than usual. In one case, the SLA would be fine and nobody would panic. On the other side, people would scramble around and try to fix the problem. When is the database needed? Is it 24/7 or just office time, 9 to 5 every day? Yeah? or just once a month or twice a month for payroll. Yeah, right. If I have talked to our payroll guys here at the company, if they tell me, hey, yep, every 10th and every 20th of the month, we need the system to be running, or every 10th and then 25th of the month, we need the systems to be running. This is the day we run payroll. The rest of the month, it's great if it's running. If it's not, we give you a day to fix it. On these 2 days, I want it. I come, or imagine IRS. Yeah, their systems to file your tax return. Yeah, most of the year they don't give it anything if it's running or not. Once a year, come April 15, that system is better running as clockwork because millions of Americans want to file their tax returns. And if this thing is not running, lots of people are in trouble. And the other one is, do availability requirements apply all day long? Or is it different at different times of the day? I already gave the example with the financial company that says we only need to trade between 4:50 and 5 p.m. Yeah? The rest of the day, we don't care. We can run with a low SLA. These 10 minutes, everybody needs to be ready and help us if there's any issue. Service windows. One other very important thing to put in an SLA. When can I take the systems down to make changes? Yeah? And you might be lucky that you work in a company that's just doing 9x5, mostly a thing is, or 16 by 5 days or something like this. Or you work in a company that is 24/7 because it's online business now, and everything, if it's not running, everybody panics. From a DBA perspective, the more service windows time you have, the better. Because same with your car, if you take well care of your car, you put it to the oil change, you put new tires on it all the time, the better it will run. You don't do any maintenance to your car, it will still run for a couple of years, but then one day you're in a hurry and the car tells you, nope, I don't feel it anymore. If you think it's not saying if you maintain your car all the time, it will run all the time, but the chances are overall better than if not. Yeah. And this is an example that I actually put in one of my SLAs. Every night from 11 p.m. till 5 a.m., all day Saturday and Sunday, except the weekend before the year-end results are due. Yeah, this was some minor system in the gambling company. Yeah, so every day, 11 p.m. till 5 a.m. in the morning, we could do in the systems whatever we wanted. Every weekend, we could do whatever we want. And I remember now it was the data warehouse. Yeah, but year-end results where we had to file for all kinds of permits or so for the next year, they needed this system to be up and running because every cent, whatever information they wanted to get out of it, needed to be done. And that's great because there was no planned maintenance at the end of the year, all that. We scheduled everything around it. We made sure that the months before that and the weeks before, we got the system into good shape. Everything was ready so that for the 1 year weekend, the last one of the thing, containing the last week of the year, everything was fine. Yeah. Another one from reality. Hey, every Sunday, every first Sunday, every month, between 2 a.m. and 4 a.m., you can do whatever you want to the system. That's a tough one because that means some DBA has to get up at 2 a.m. in the morning on Sunday and do this. And you only have 12 times 4, so 24 hours a year to do maintenance. The next big thing is planned and unplanned time. I've seen so many times, oh yeah, we had 99.99% availability. Oh no, planned outages that we take every week 3 hours, they don't count. That's very different. So in most companies I worked for, planned, unplanned, and planned time was accounted the same thing. There's a budget per year. This is how many minutes the system can be down. The business didn't care if this was because we planned patching or if this was because something failed and the system wasn't running. In either way, it cost money. Yeah? The advantage of planned maintenance is that you can schedule it at a time where it's the least harmful, while usually outages happen whenever they like it. But it's a big debate. And again, it doesn't matter what the answer is, as long as it's specified in the SLA. it's clear to everybody, and there's no discussion point when it happens. And there's a big difference between the two cases. Yeah, clearly understand. Thing is, monitoring availability, and I explained this before. If you have these famous 5 nines, that means 5.2 minutes per year of outage, or 0.8 seconds per day. This requires you to do an availability check at least all 0.4 seconds, because otherwise you're wasting failover time. Yeah? If you're not detecting, it's just imagine you check once every minute, a second after the minute it happens, for 59 seconds, you will not detect that you have an outage. That's 20% of your overall downtime you have. Yeah, so you want to then monitor this, and this is where you see it gets really hard, because if you hit your system twice a second with monitoring checks, yeah, that's already a big load on the system. So this is where it comes in. Do we really need that? 5 nines are great, but honestly, do you need it or not? Yeah, it is. And by the way, if someone requires these 5 nines, that also means that every transaction has to finish in less than 0.8 seconds, because otherwise a simple rollback of that transaction when you fail over already violates the SLA. And this is the next point I want to get to, and I think I don't have a slide on it, but I want to talk a little bit about it. Whenever you do a failover with SQL Server, doesn't matter which technology, in every technology, and it doesn't matter if this is a simple restore of a database, you do log shipping, mirroring, always on, failover cluster instances, or anything else you can think of, what they all have in common is their failover time to actually failover varies between several hours for backup restore, down to minutes with log shipping, down to seconds with always on. But after the failover happens, the system has to come online on the other side and has to recover the database. And that's the point where for all these systems, the clock runs at the same speed. If you had a transaction on the other side that was running for 3 days, and you fail over in the middle of that transaction after 3 days, you will have 3 days of rollback on the other side. And in these 3 days, you will not be able to access the database. And with 3 days, I'm exaggerating a little bit. The longest practical case I ever had was 27 hours. There was an open transaction that was 6 weeks old. Lucky the transaction didn't do anything. It was just someone opened SQL Management Studio, said begin transaction, did one update to a little table, went on vacation, forgot about it, and then the system failed. And on the other side, it had to go through 600 gigs of transaction log to just figure out nothing has actually changed in this 6 weeks, and we're all good to go. But it took 27 hours on a little tiny VM to do this. Problem was the VM had enough storage to actually store 600 gigs of transaction log. So sometimes having a bigger system doesn't help you. More availability. Talked about this before. Having availability, it's easy to end up with 100% availability. A little bit of luck, average systems that don't suck, and you're good to go. It's easy to have a year with 100%. Guaranteeing 99.7 needs a very good team, good routine, lots of fire drills, and everybody in the team needs to know what to do. Yeah? And this is what we had at the gambling company when we lost, where every minute of loss of downtime cost us like $100,000. What we had to guarantee was 99.7. Yeah? So every time, but this included planned, unplanned, whatever. The management didn't care why we were not running. What they wanted is the website up and running and people can spend money or they can't. Yeah? They didn't care why. Yeah? So every time I hear people talking about 99.99%, it's great that you have that for the last 3 years, but you are not guaranteeing it. Yeah? You are just getting lucky. Difference between high availability DR and what I like to call last resort. High availability, disaster recovery, last resort. You should have different RPO and RTO values for all of these three cases, yeah? Because there are different failures that can happen, and this is usually very easy to explain to management. There's a big difference if a network card or a hard drive in a server fails, and we have to deal with that situation, or if a data center is no longer there because an earthquake leveled the area. It's not there anymore. Yeah? So that's a big difference in handling it, and management usually understands there are different recovery times between these scenarios. If not, then the disaster recovery equipment and everything has to be at a certain amount that probably costs the same as the production environment. And if the company is willing to spend that, that's great. But normally cases is that the DR sites are smaller, have less power or less computing power, less resources, and are usually in a lower quality data center. But again, it depends on company. Important thing is it has to be written down, and you have to defend the worst case scenario that each one of these scenarios handles. So let's have a look at the examples. High availability today, people expect the recovery time objective. So how fast are we going to fail over to be seconds to minutes tops? Yeah, it's like, hey, something's wrong. You automatically detect it. You fail over to the other side, and it's fine. The recovery point objective for high availability today, most main company I work for is 0 top seconds. Yeah, so most companies expect, hey, in an HA scenario, I'm not losing any data. I don't have to worry about it. It just runs on a different system and everything's fine again, and we have no issues in this case. Yeah? So this usually high availability requires automatic failover, and the high availability site is usually either very close or even in the same data center, or in the same room, or in a different aisle within the same room. So it's in many cases the systems are really close. The farthest away I've seen is about 30 miles. Because everything above that is more than a millisecond, and then high availability and zero data loss become tricky. And it's usually well tested. And in most companies I worked for, patching and the release cycles are very good candidates to actually trigger high availability events. So what I really like to do is I have my two primary and HA system, and every time we have a patcher, so we fail over between the two, and then for the next month run on the other one. So I always know that they're both pretty much in good shape. Disaster recovery, this is when the failures get tougher. Yeah, then the recovery time is somewhere between minutes to hours. Most disaster recovery I've seen is manual, because it's usually the data center is a couple of 100 miles away. That means there's no more synchronous data exchange. It's all async, so the data is slightly behind. So it's a good idea that a human being makes the decision, hey, we're actually going to go to DR and risk small amounts of data loss in the seconds to minutes, sometimes even hours, but it's worth it. Versus what I've seen many times is the primary data center loses power. You call the data center, they tell you, yes, sorry, we forgot something. We're firing up the generator right now. It's going to take 3 minutes, and in about 10 minutes, you have power back. It's not worth to go to DR. Yeah, because in 10 minutes, your primary site is probably going to be up and running again. Then you evaluate, is everything working fine? If not, you switch that individual system to DR instead of moving the whole company to DR. Still, it's basically a manual failover into a prepared environment, 100 miles away, and it's tested from time to time. Most companies do like once or twice a year a DR test, sometimes all of the companies, sometimes just department by department, depending how much time they want to spend doing this. Last resort. This is something not every company has. I've worked in a couple where it came in very, very handy. Recovery time is days to weeks. This is not something you're planning on, but you have a plan. What happens if all your data centers disappear? Yeah, and I can tell you, if you work in the online gambling industry, this can happen. We had a multi-government strike against our corporation, and 7 countries cut the fiber optic lines to our data center at the exact same moment. They all had SWAT teams. Lucky for us, they missed one. So we kept running, but if that was not the case, we would have had a plan how, with a new data center in a country we've never been before, we would have been up and running in about 2 weeks from now. Yeah. Yeah. It's basically you rebuild systems from scratch. Uh, you might have to order the hardware, but you have a list what you need. You might not have the money, but you have an agreement with a bank to give you a loan in this case. Yeah, you have pre-arranged options on floor space in data centers, stuff like this. Yeah? And in today's day, it's much easier. That might be your plan is, yeah, it's finally time to go to the cloud. Yeah? And the last research site is usually in a different continent or at least in a different jurisdiction to avoid things, because last resort, that's not a natural disaster. Last resort happens if there's a planned attack against your company, which might be either the government or the competition is literally trying to wipe you out with either lawsuits or some evil attack against you. And you need to have a rough plan how to go through this. Okay? And you might or might not want to do this. I'm just putting it here to be complete. You have to define the worst case scenarios: failure of a single component, failure of 2 components, which are of different kinds. So your high availability will work if you lose a network card and a power supply, but it might still work if you fail a whole server, you lose a whole server. It might work if you lose multiple servers. This is a tricky one. Failure of any 2 components. And failure of any 2 components means that you need at least 3 of everything, and that's not really easy for disks. Yeah? Because any 2 components means you have a server, you have 2 network cards in it. If both network cards fail, it's very unlikely that that server has a 3rd one. Yeah? And the same goes for power supplies and most other stuff. Yeah? So when you say any 2 components, you most likely have to have 3 to fulfill that. Any 2 components which are of different kind is easy because 2 different things fail. 1 network card, 1 power supply. Both power supplies, most likely not survivable. Yeah? Very different scenarios for DR. Yeah? Human error. Someone deleted something. Someone yanked out the wrong cable, shut down the wrong server, rolled out the wrong software, deleted something. Yeah? Failure of a server could be a DR scenario. You say, hey, could be HA, could be DR, depends what you do. Failure of multiple servers is most definitely in most companies a DR event then. Partial or full failure of a data center, most cases that's considered DR. Hey, whole data center is down, let's switch to the other one. Failure of multiple data centers, that's the edge case, because this is where most companies then would go to last resort plans, but it could still be handled by DR. Thing is, last resort, destruction, failure of multiple data centers, that's where it begins. Natural disasters, you have your data center 600 miles apart on the East Coast. That still didn't stop Superstorm Sandy from destroying both of them, because one was down in Florida, the other one was up in New York, and the storm hit within a day both. Then you have to go to your last resort. Sabotage, again, your competitor sends out evil little ninjas and they destroy your data center on purpose. Very rare, but can happen in other countries that are more run by illegal organizations than by governments. A very common scenario. Political incident, war, regime change, lost elections, all kinds of things can trigger that. And destruction of planet Earth. That's the only one I've never lived through. But there's strange companies that actually shoot backups into space. I don't know where they plan on restoring them, but hey, it's their money. And this list can go on. A lot of things can go wrong outside of SQL Server, and your SLA should specify that, A, you are not responsible for that. Yeah? If the data center loses power, that's not your failure. Yeah? You have to plan for it, but you are not the one responsible for making it working again. There's a data center team doing this. Yeah? Make sure there are no interfering processes. I worked in the gambling company, and we had that case for one case where we had an async mirroring to another data center. A manager had to give the okay that it's fine to lose the data if it said okay. The problem is, due to some personal changes, at some point he was the only person, there was only one actual physical person that could give the okay. In Europe, a person can take a 3-week continuous vacation without getting fired. That would bring the availability down to 94%, because if nobody's here to make the decision, we couldn't technically not fail over. I mean, you always find then some CEO or so that makes a decision, but it shows that there are sometimes processes that can stop you from failing over or becoming online again, versus actual just things. Other ones are dependencies. Who actually needs this database? What does this server need to operate? Power, cooling, network, firewall rules, domain controllers, other servers. Magic keyword is linked servers. Yeah? Great, my server is running. Server from the other team is not running because now my query stops because I was stupid enough to put in a linked server query. Responsibilities. Yeah? Who can actually make a decision for a database or a server? And this is something that's always forgotten. I try in every company to have a clear list. This database, that's the person, and that's its backup, and that's its second backup. Anything wrong with this database, and we need to make a decision. Can we roll back for an hour? Can we restore to yesterday's data? Can I give you the corrupt copy, but give you yesterday's data, and then we copy the data over once we figured out what's wrong? Yeah, a decision like this. Yeah, there needs to be someone who is actually owning the data and gives you a clue. Who owns the data? Basically, might or might not be the same person who makes the decision, but very good to know. Yeah, and who needs to get a message if something goes wrong? Yeah, and when you have this in your SLA, you will see how people like you as a DBA, because most of the cases, people are just angry because they didn't know what was going on. Hey, you have a name, a database goes down, a server goes down, you notify each one of them, you might have automated that process. They get an email, hey, we're already on top of it, we're already dealing with it, it's down, we'll let you know, we give you the next update in 15 minutes. In 15 minutes, you all send them like, hey, it's all clear, or you tell them, hey, we already identified the problem, we're working on it. It helps so much. Backup retention and granularity. Yeah? How far you have to go back. Yeah? And this is one of the last things I consider part of the core SLA is how many years, days do I have to go back, and how accurate must I hit that restore date. Yeah? Do you get a request? I need restored to November 15, 2008 at 6:27 a.m. in the morning. Unlikely. Most of the companies are like, hey, we need to see how the data looked like in November 2008. And then you give them the option, yeah, I have a backup from the 1st, I have one from the 15th, and I have one from the 31st. Which one do you want? And then they give you an answer. Yeah? But I've worked in companies where a lot of money was at stake. They wanted to be able, hey, we need every transaction log backup, every differential backup, everything kept with 3 copies for at least 7 years. Okay, then you can do that. Yeah. And how much time and space do you need for these historic backups? Because they usually don't go on top of the existing database. They usually go into a separate space. So you have to be planning on how quickly this is. And everybody who ever used Glacier in AWS, it's great to put the data up there unless you have everything lined up and you need it back. That can be taking a while because you need to provision the space where you put it. And every backup should, of course, be tested from time to time, and you have to budget for the resources and time for that. That's just the general. Don't get fired as a DBA rule. Tips for keeping the SLA. Make sure your monitoring and alerting works. It's great that your monitoring figures out something's wrong. If it can't reach you and tell you something's wrong, there's nothing you can do about it. Yeah? So working monitoring that doesn't produce noise is key to actually being able to measure and ensure you're keeping the SLA. You have to monitor your monitoring. I've seen cases where the DBAs were smiling coming in on Monday. Hey, not a single error on the weekend. And everybody's yelling at them. And then they figured out the monitoring was not running all weekend and hundreds of things failed. Yeah. Test your HADR last resolution solutions as often as you can. Again, I use patching, I use rollouts as very good candidates. Someone else requires downtime anyway, so I sneak in a test, failing it over. It's better to have it tested than regularly have it someone complaining about something small wrong. And we all know this. It's a problem. You have 3 servers for high availability and DR, and every time you create a login, you forget it on the other 2. And I'm as guilty as everybody else from probably having forgotten it a couple of times. You can write as many runbooks as you want. There will be a situation where it's urgent, where you're like, yeah, I'll do this tomorrow, and then it never gets done. Yeah. Also very important to keep your SLA, have disaster recovery and HA and last resort instructions. Yeah. Keep a printed copy. When your databases are down, you will not be able to access your SharePoint or your wiki because these guys are running on a database that is currently down. And I've seen so many people spend the first 3 hours of the DR just getting the documentation out of the systems. Yes, it's paper time and it might cost the life of a tree. But if you run a multi-million-dollar or billion-dollar corporations databases, every couple of months, spend the back of paper, print it out, put it in a binder, and make sure that every DBA knows where the time binder can be found. It's just thing is. That's the last slide, so we're almost at the end, and I have 3 minutes to go, so we're good in time. What's possible or not? I've made this nice little slide, which I noticed while talking during the day that I forgot failover clustering because I haven't used it in so much long time. But what this chart shows you very, very easily, on the left side, you have the various ways of doing high availability and all the tools that SQL Server gives you. Backup restore, log shipping, mirroring, always on without a space, 2012, always on with a space, 2014, and yes, you can send Ellen Hurt a message that I made this very clear, 2016 and 2017, and then there might be a version next. And I basically colored green what works well on these versions and red and was not. So if you want to look for zero data loss, you need at least database mirroring or always on in any of the versions. With that, you can do synchronous mirroring. That means every data that's on this side gets committed on the other side, you will not lose it. With backup restore, you're always hinking behind. You can take log backups every 10 seconds, you're still 10 seconds behind and you might lose these 10 seconds of data. Yeah. Yeah. But if you want zero data loss and high availability DR, they are somehow mutually exclusive till always on in 2017. While your system works great when the primary fails, it will immediately go to the secondary and you have no data loss. The tricky part is before 2017, when the secondary fails and the primary keeps running, you don't have the data on the secondary anymore. And if then your primary fails later, you have technically data loss. And 2017 has a feature that finally forces the data to be on both, and doesn't matter which one fails first, the other one gets stopped as well. Can you have automatic HR? Yes. Starting with mirroring, it always there. Can you have automatic HR and automatic DR? Yes. Starting with 2016. Wasn't possible before, it's possible in 2016 now. Is there anything in the system that will help you with long-running transactions and make them recovery fast? And as you can see, it's a very red slate all the way down. There's nothing you can do about it except kicking your developers to avoid long-running transactions. Thing is, there's a question mark in vNext. I cannot talk about it, but we might be getlucking sometime. And drop data protection, which is basically means if an application accidentally deletes data, all the high availability tools will immediately make sure that's happening on the DR and the HA copy of your database as well. So if you want to have all green, right now you have to do three things. You have to choose a high availability, whatever your SLA says you need. You have to choose a high availability option. You still have to do backup restores and log shipping, because that's the only way you can protect your data from being deleted accidentally. Yeah. And you have right now have a serious word with all of your developers and people that write applications and run applications that if you run very long transactions, failing over to the other side can take a very long time. Yeah. And this is it for the talk about SLA first. There is the second part of this talk that's called from SLA actually getting to the solution. And I'm pretty sure we can somewhere later this year schedule another time. If you're interested, let us know. I'm pretty sure there's some awesome feedback system in this whole virtual chapter. If not, one more summary. SLA first. That's the rule number one. Solution later. Don't agree to an SLA you can't support. And the laws of physics applies even to the best DBA. You can't go faster than the speed of light. That means your restores will take that much time to move the data from one end to the other. I guess. So that's it. If you can ask me questions now, I'm pretty sure Shannon will kick in and do the moderations of these question things. If not, you can write me an email, and I usually try to answer within a week. Okay, thank you very much.
Thank you, Thomas. I've got a couple of questions. Do you have a template of an SLA that's related to a database server environment?
Yes and no. I have a bunch of SLAs that I use usually and then start from there. I don't have this like nice little template where it's like a form with insert name here. But I will dig through my documents and see if I have something that's very similar. And if so, I will send it to you, Shannon, and you can edit the slides.
Send it to me and I'll post it on our webpage.
Yeah. Mm-hmm. I'm pretty sure I have something that's at least shows how I write it, and then we can probably as a group make it a template.
Okay. And what do you use to monitor uptime?
Very different in every company. In the gambling company, we use the data warehouse that was to monitor availability. It was very clear. The definition was we have 400 different games, and each game must make at least $1 of money every minute. Then the game was considered available. If not, the game was not available. And normally these games made thousands of dollars per minute, so it wasn't a stretch. In other companies, I've used Idera, I used Redgate, I used Quest, I used SQL Sentry. Did I miss anybody? I don't want to think. It usually, whatever the company wants to use, I've used HP OpenView, I used SCOM, I used Xenos in the open source world. Whatever monitoring system the company has, I usually tagged on because I don't see it as the job of the DBA team to implement a monitoring solution. That's the job of whoever monitors the enterprise. The actual math about the availability is usually part of then you query the data they collect, because most monitoring systems just collect data. They don't calculate an actual SLA. Because again, as you've seen, it took me an hour to just list basic options of an SLA. Nobody wants to put that into a software with all the options to actually do the interpretation. But normally what happens in a company, you take all these SLAs you have, and and you talk to all the different systems, and then you come up with a little matrix that says gold, silver, bronze. And then you have three, and then you have three formulas how to take the monitoring data, whichever system produces it, and calculate the availability out of it. Yeah, so whichever monitoring system you're comfortable in is a good one.
Okay, thank you very much, Thomas. That's all the questions we've gotten.
Okay.
Please remember to send me your PowerPoint so I can post it with the recording and
Okay.
any supplemental materials.
Yes.
Thank you. It was a very interesting presentation. And send me information about the second part because we might want to slot that in at some point.
Yep. Thank
Okay,
you.
thank you. I'm
Bye.
going to end the meeting now. Bye-bye.
Bye.